The following podcast is a proud member of the Blue Collar Roots Network. Find all the shows by visiting bluecollarroots.com. It's like your favorite call-in radio show, without being able to call in, and without being on the radio. Building HVAC Science with Bill Spohn.
Welcome back to another episode of the Building HVAC Science podcast. I'm your host, Bill Spohn, and I've worked in the HVACR and building performance markets for over 30 years. And I've noticed the need for scientifically rooted information on how to do a technically correct job. I offer this podcast as a means for various people I've met along the way in those 30 years to communicate what they're doing and give you some insights into the more human aspects of the trades, building science and HVAC. In today's podcast, we hear from John Sheff, who was the Director of Public and Industry Affairs for Danfoss at the time of this recording. We learn how John's passion about energy efficiency, decarbonization, and sustainability combines with his professional experience in public affairs, government relations, and project management to help develop strong solutions that meet our industry's needs. John discusses the barriers to deep energy retrofits, the limitations of the push for electrification, as well as how people are thinking beyond the individual building to tackle building emissions. We also talk about the needs for variable speed technology in HVAC systems that can ramp up or down to accommodate commercial space that is operating at varying degrees of capacity. And we touch on the need to maintain constant variable airflow as opposed to the on-off airflow in indoor spaces with respect to what we learned in response to COVID-19. There's some links in the show notes where you can learn more about Danfoss products, and you can read more on Danfoss's position on ESG at a link in the show notes. This episode was recorded in August 2021. Let's hear our discussion between John and I about energy efficiency, decarbonization, and sustainability. John, how are you doing today?
I'm doing great. Thanks for having me, Bill. Excited.
Tell me a little bit about your role at Danfoss and a little bit of background about you.
So I am the Director of Public and Industry Affairs at Danfoss, and so I handle all of our government relations at the federal, state, and local levels as is needed, as well as our thought leadership and our interactions with our various trade associations. And for those of you who don't know, Danfoss is a global manufacturing firm, and we manufacture components across various industries in HVAC, which we'll mostly be talking about now, but also in power electronics, in our drives division, and interestingly in hydraulics, so mobile hydraulics for large construction agricultural equipment, as well as industrial applications. And be remiss if I didn't say today, we just closed on a very large acquisition of Eaton's hydraulics business. So a big day for Danfoss, but we'll be mostly focusing on our HVAC components here today.
Great. So Danfoss, give me a little bit of history on the company.
So yeah, Danfoss is more than 75 years old. We're a Danish company, although we have deep roots here in the U.S. also. We've been here for more than 50 years in one form or another. And like I said, we're divided up into three main divisions: climate solutions, where we cover HVAC and heating applications; drives, where we manufacture variable frequency drives and power electronics; and power solutions, like I mentioned, where we manufacture hydraulics for mobile applications and for industrial applications as well. And here in North America, this is Danfoss's largest global segment or global region. And with this acquisition of Eaton, we'll do probably a little more than $3 billion coming up.
Wow, so pretty awesome. So I know another person who's Director of Public and Industry Affairs for another company, but what's your work month look like? Not day, that kind of thing, but over the course of a year, what do you do? Where do you spend your time?
Yeah, I mean, it's interesting. And one of the things I really like about the job is that we're doing different things every single day. So I'll just say a bit about my background. I come out of state government. I worked in the office of former Maryland Governor Martin O'Malley in Maryland, where I was a policy analyst, senior policy analyst covering greenhouse gas policy, energy efficiency policy, renewables, smart growth, some economic development. So a lot of different things. I started at Danfoss after I got my MBA from the University of Maryland. And I've been with Danfoss for 7 years. I've done a bunch of different things, from business development within HVAC to some project management within our organization. And now for the last several years, getting back into the policy realm, doing public and industry affairs. And so in my role here now, like I said, I manage government relations. So when we have an issue, a specific issue, I engage with a congressional office, with a Senate office, or with a state office also. And this could be anything from trade, from tariffs we've dealt with, to tax issues and things like that. And then on more of an industry level, we really engage through our industry organization. So we're very active in AHRI, the Air Conditioning, Heating, and Refrigeration Institute, where I sit on the Government Affairs Committee. So I just actually got off a call having to do with tax incentives that we're looking at for the upcoming reconciliation bill or the end of the year bills, omnibus bills. We handle all things at those trade association levels, say the AIM Act, the American Innovation and Manufacturing Act, which was just passed last year, which deals with the U.S. refrigerant phase down. We lobbied very heavily on that, but we kind of go to market, as they say, through our trade association. So we do some individual lobbying on our own, but mostly as it relates to specific issues, like I said, tariffs or something like that, that specifically relate to Danfoss. But within industry, we usually go to market through our trade associations, like AHRI. In addition to those activities, I do a lot of thought leadership. Last year, it's mostly been online, but before the pandemic, I was traveling a lot, conferences, doing speaking roles, panels, that sort of thing. So my monthly or annual calendar is very varied, and I'm getting back to traveling more now, which is a good thing, and getting in front of people because that's really what I enjoy most.
Fantastic. So you must have to pull some technical resources because this is a very technical field. Your company makes technical products.
It is. I mean, we're an engineering company at our heart, and we're full of engineers. I myself am not an engineer, but I do work with engineers all the time. And actually, I find it useful to be coming from a more policy and communication standpoint and communicating what our engineers do and what the issues are, the problems that we're solving. But it does help to have a background and be able to understand the things that we're working on.
So we're going to talk about 4 topics or so, which you had proposed. And I like the topics. I mean, it immediately attracted me to this podcast because I think it touches on a lot of things that should be on our listeners' minds. The first one was on barriers to deep energy retrofits. It's messy. It's complex to get to where people think they should be. And your company has to create solutions or paths to get there. So do you want to talk a little bit about what you see as barriers and how you might overcome those barriers?
Yeah, I mean, this is a topic that I'm really passionate about. I also have a degree in sustainable development and real estate development from the University of Maryland. So this is a topic that I've thought a lot about, particularly in commercial buildings and, say, multifamily buildings as opposed to residential homes or single-family homes. So we talk about commercial and multifamily buildings. Yeah, there are a lot of barriers. And we know that the turnover in the U.S. in terms of real estate is small, maybe 1 or 2% a year. So to solve the climate crisis and the 40% of emissions that come out of buildings, we really need to get after existing buildings. Just doing it with new construction, with building codes is not going to be enough. But there are a lot of barriers. People have been trying to crack this nut of retrofitting and deep retrofitting buildings for a long time, but they keep running into these barriers. And one of the biggest ones I think that we're going to eventually crack soon is a split incentive between tenants and landlords, where the landlord is responsible for the capital improvements in the building, but the tenant, through triple net leases or net leases in general, is responsible for the utility bill. So they would reap the benefits of lower utility costs. And so that mismatch, that split incentive, really holds a lot of capital improvements back in particularly tenant-occupied commercial space. But I think there's some innovations coming out. I think utility companies are getting involved in some of the retrofits, which we've seen some pilot projects. There's one in the Pacific Northwest with Seattle City Light, municipal utility up there. They're doing energy efficiency as a service. That's designed to get past the split incentive. We've seen some innovations with green leases. And I think that some of these building emissions laws, like we're seeing in New York with Local Law 97, where there are emissions caps and heavy fines for missing those caps or going over those emissions caps for a building owner, I think that could get past some of these split incentive barriers. Beyond the split incentive, initial cost. First cost is a big thing. Some of these retrofits are expensive. The buildings that were initially designed were not designed to house some of this technology, whether they're very efficient chillers or when we talk about decarbonization, a heat pump in place of a boiler. These buildings are, some of them, particularly in places on the East Coast, 100 years old, 50, 75 years old, and they're designed to have boiler rooms, not designed to house more efficient equipment, whether it's on the roof or otherwise. So those are some of the barriers, very physical barriers or engineering limitations that we need to get past. I think with technologies like modular chillers, modular heat pumps, where we can do these things in pieces, I think there are ways to get past them, but it does take some creative engineering and some creative financing too.
So that would be where Danfoss comes in with the modular chillers, modular heat pumps?
Yeah, so a lot of our customers are these OEMs, original equipment manufacturers that manufacture the end units. We manufacture up to 70% of the components that go into a high efficiency chiller or a high efficiency heat pump. So The OEMs are our customers. We're working with them from day one through the engineering cycle. We have our application development centers around the country and around the world where we have lab space and really space for our customers to do some innovative testing of the equipment that they're using. So we're working with our customers and working with the applications every day to try to get these important applications that can be used for retrofits.
Can you name some names of the customers, the OEMs?
The big OEMs that you have heard about, Trane, Carrier, Rheem, Lennox, Smart is a really cool manufacturer that uses our turbocore magnetic bearing compressors to make some very, very efficient chillers. Those are some of the companies that we're working with on a daily basis.
Are you at all in the aftermarket?
Yeah, of course, we work in the aftermarket, but our bread and butter is really the OEM business and helping these companies get to their goals and helping their customers get to their goals, so the end users. But yeah, of course, we do play in the aftermarket as well, and you can find our parts at our many distributors.
So staying in this topic of barriers to deep energy retrofits, do you have a counterpart in Europe since you are a Danish company?
We're a global company. We have, with this recent acquisition, more than 40,000 employees worldwide. So I do have counterparts in Europe, especially in the EU, where the regulations are somewhat more onerous for buildings.
Yeah, that's what I want to draw out, the contrast.
Yeah, so I'm basically a one-man show here in North America. I handle all of it. In Europe, we don't just have one European region. We have a Central European region. We have a Northern European region, a Southern European region. And so they all have people like me working there. And then there's an overall team that kind of ties it together in Brussels dealing with EU. So it's a more comprehensive team in Europe. And of course, our global group public affairs sits in Denmark and Copenhagen, where we're headquartered. We're actually headquartered in southwestern Denmark, but we have a presence in Copenhagen, of course.
I can see where your background with Governor O'Malley's office and the greenhouse gas, energy efficiency, renewables, sounds like that's got to be part of the mission or vision of Danfoss. That's the reason why they hired you?
We're very climate focused. We have a climate commitment now where we're going net zero energy by 2030. So we're well on our way. We're actually looking at ways to do that and offset our energy usage here in the United States through power purchase agreements, and that's ongoing. We're starting our ESG program. So Danfoss is not only do we make the most efficient and high quality products on the market to help our customers and their customers achieve their climate goals, but we're actually going through that journey also.
Well, that's pretty awesome. I mean, to also walk the walk of your customers is very important.
Yeah, I mean, that's really what we're all about, and especially a company with Danish roots where we are very, very focused on climate, very, very focused now on decarbonization and pursuing energy technologies and energy storage and hydrogen and trying to get out in front of these trends also.
It seems like, from my perspective, you have to have a lot of horses in the race because there needs to be a mix of solutions available, as well as you don't know, it's hard to see which one's going to be the resultant successor in 10 or 20 years.
I think that at this point, we kind of know, Bill, that there's no silver bullet. It's going to be a mix of technologies, a mix of renewable energies that are going to help us get to a carbon solution in a decarbonized world. So we are, through our various segments, we're involved with, like I said, battery storage. We're also now very involved with hydrogen, particularly in Europe, and we're starting to have those conversations here in North America too. We think there's a place for all these things, particularly in some of these applications. When we talk about electric vehicles, say, a lot of the battery electric gets a lot of the attention. We're very involved there also. But I think there's a place for hydrogen, particularly when we talk about off-highway applications that require a lot of horsepower or long-haul trucking, where we're involved in too. Our Editron division manufactures electric drivetrains for electric buses and electric trucks. So we have our hands in a lot of different pots and a lot of different technologies, but mostly all of them dealing with sustainability and decarbonization one way or another. We have oil and gas customers, but even there, we're helping them become more efficient, helping them use less energy in their operations. There's a place for all of these technologies across the economy, really. And I think decarbonization is a trend that's not just about industries focused on sustainability. It really is about all industries and all corners of our economy. And I think we're going to see that in the years moving forward.
How long have you been in your role?
I've been in this particular role a little bit more than 2 years now.
Have you seen any particular acceleration or change on this topic area, this very broad topic area we're talking about?
Decarbonization, and this is kind of a new word. Even just a few years ago, we used to talk about it as electrification, but I think we're still talking about electrification, of course, but really this buzzword of decarbonization has come to the top too. And in the policy world, when we talk about decarbonization, a lot of times we're talking about these natural gas bans that are popping up all over the place, mostly in California. We're seeing them in Massachusetts also. there's backlash to it. We've seen some anti-natural gas bans. So like Arizona has passed at the state level a ban on local natural gas bans. And we're seeing this in some other place. Massachusetts, the attorney general there has pushed back on some local decarbonization laws and saying they're not in line with the state constitution. So that's kind of at the policy level what the decarbonization means. But we're also seeing, like I mentioned, local law 97 in New York, building emissions laws, which saw something similar in Washington, D.C., which hasn't quite been implemented yet. So that word can take on a lot of different meanings. But I think in the last couple of years, even since I've started, we've seen a real acceleration of the electrification trend.
That was sort of our second topic. And you mentioned some of the limitations that are coming up in some locations. And you're saying kind of the brief here was geographic reasons and technical limitations. Can you break those two down a little bit?
We see electrification in a lot of different places around the country, and sometimes it can mean different things, whether it is a natural gas ban in Berkeley, California, where they're trying to get off natural gas for new hookups. That approach may not work in a place like Minnesota, where we have very deep winters, and going to all electric heating may not be advisable. Say we do have cold weather heat pumps, that the technology has come a long way, but people may not feel comfortable like that in a place like Massachusetts, say, or a place like Minnesota where they have very deep winters. So there are still some technical limitations, and I don't think banning natural gas altogether is a right move. This has to be somewhat of a smooth transition as we kind of get to a place of decarbonization. I don't think that banning one technology or another at this point is really the right approach.
But certainly those bans do develop dialogue, or at least discussion, maybe argument even.
I mean, they've certainly developed a lot of discussion and people are taking notice now. I think the utilities are in an interesting position because we've seen in some places where PG&E in Northern California, for instance, they signed off on the gas bans. And it puts states in an awkward position also because they're now, California could have a patchwork of gas regulations across their state. It forces the states to get involved. So it definitely does spark a conversation about decarbonization, about the best way forward, about what happens to these stranded natural gas infrastructures that we have. Can they be used for hydrogen? That's one idea I've seen pushed around. So the conversation is definitely starting. And I think it's accelerating too in a way that we haven't even seen just a few years ago, really.
And the title of the podcast is Building HVAC Science. So it's about the building science where you can have going all electric. Probably the first step you want to take a look at is just using less energy to do the same process, and whether it's heating or cooling, and then to look at less expensive or more electrified means of doing that. Do you get in crossover in your company into any kind of recommendations or pointers that way? I mean, do you just go with the flow, or how does that work?
We are definitely an efficiency first company. So that's what we specialize in. Although we do build components for renewable energy and other types of generation.
For equipment and machines, yeah.
For equipment, exactly. But we're all about efficiency, and particularly when it comes to buildings. In fact, the president of our climate solutions division just published yesterday an article in the Cooling Post about efficiency first and how, in relation to the climate package that the EU just passed or wants to put forward, how efficiency really needs to be a big part of it, because we can't just take all the heating load that we have, whether it's from natural gas or coal, whatever it is, or in buildings, whether, natural gas boilers, and dump it onto the electric grid. Our grid is not built for that. We really need to make sure that we're doing things as efficiently as possible first before we do that. So you're right, Bill. I mean, when building owners talk about electrification, when they start thinking about it, they should really look at how can I make my building the most efficient it can possibly be before I really start talking about electrification and really looking into, say, if they have a chiller boiler set up, going to a heat pump or something like that. Their building can really benefit from an efficiency first approach.
And I would strongly recommend listeners to look up the Cooling Post. I subscribe to that. That is one awesome newsletter.
And it's a great resource.
Certainly. We want to sort of move into talking about beyond the individual buildings to talking about building emissions in general, putting things together in neighborhoods or blocks. You mentioned the topic here, an efficiency district. Flesh that out for me.
This is a popular notion in Europe where we do a big business in what we call district energy. Let me preface this first by saying in the US, we typically think of efficiency, or we think of a building as its own discrete system. So like I just talked about, let's make that building as efficient as possible. Let's upgrade the HVAC, the lighting. There are more efficient approaches to that though, and it would be looking at a group of buildings, a neighborhood or a campus, say a hospital, a military installation, a college campus, as its own discrete district in its own system, and the buildings within that system sharing resources as they're needed. We can have these highly efficient district energy loops where we generate heating and cooling, really. We can do that too in a central location and then distribute it to the buildings through, it used to be steam, but now we use low temperature hot water mostly. And then cooling, we can use glycol to distribute energy and heating and cooling services to those buildings as they're needed. So if you think about a traditional building that has, say, a chiller and a boiler and uses a hydronic system to move water to heat and cool the building, think about a group of buildings and this district energy system running between them as that same loop. But instead of just a building, it's moving through a whole district, and it can optimize which building needs how much water or how much heating and cooling. And that is really how you get the most efficient setup. And even if you're generating that using, say, natural gas as a fuel to generate the heat, it's still a lot more efficient than doing it at the building level. And you're going to be using a lot less energy. So it's really the idea of sharing resources through a district.
Got it. So the independence has its cost, building independence.
That's how this country is set up. Every building owner has their own building. They don't want to depend on another building or share resources with another building. But like I said, in Europe, we have different setups there, and we're getting some very sophisticated resource sharing. In fact, we have projects at Danfoss where we're using waste heat from a supermarket's refrigeration system to put that into the district system and district energy system, and use that heat to provide heating for homes and for other buildings. So really some pretty interesting stuff is enabled when we can share resources between buildings.
It harkens back to an older concept of district heating in some of the older cities in the United States.
Oh, 100%. We have these systems. And like I said, traditionally there's steam in places like Chicago or Minneapolis. In Canada, there's a lot of them. But this is an old concept that turns out to be a pretty good one. And in the 21st century, we can replicate it or even adapt those existing systems to meet our needs.
Do you have any programs or projects in an area that you're working on? And how do you solicit engagement?
I mean, it's interesting because this is kind of a nascent market here in North America. There's actually a good amount of activity in Canada. We've done some projects up there at some colleges and universities. But in the US, that's really where we see it mostly is we've seen military installations, military campuses, and universities, and also hospitals. But these where there's a single owner and
governing authority.
Exactly. And they can really institute it. But we've also seen some activity in places like Minneapolis where they're doing some fun things with district energy. But it's a slow developing market here. As you can imagine, these are large projects that take a lot of capital and a lot of time to develop and a lot of players.
And revision of infrastructure too.
Correct. I mean, they're big public works projects. So it's a slow developing market here, but we think it will grow in the future.
So in terms of efficient equipment, the last topic we're going to talk about was variable speed technology. And that's coming into wide adoption for both refrigerant flow and airflow. So break that down for me.
It's interesting because we're one of the larger manufacturers of variable frequency drive, and I think the leader in HVAC drives for fan motors, for pump motors, and HVAC equipment. But in truth, really, I think I saw an estimate in the last couple of years that only 10% of the motors that can have a drive do have a drive on it. So these are still very immature markets in that way. Drive technology has come a long way. When it first became available in the 70s and 80s, people didn't trust it. There were some high-profile snafus having to do with power running through it. But the drive technology has really, really come a long way, and they are very efficient and very safe and very reliable now. And so we're trying to get as many drives on as many motors as we possibly can. But basically, the technology allows a motor that is typically on-off, so it's either running at 100% or 0%, to run at different speeds. And due to something called affinity laws, and we won't get into the particulars here, but basically when you slow a motor down, even if you slow a motor down just 10%, you'll be saving much more than 10% of the energy. And in fact, when we slow it down, say, to 80% or to 50%, we're saving something like 88% of the energy. It's a big drop. And most of the time, these motors do not need to run at full capacity. Say, when an HVAC system is designed in a building, it's designed for 100% capacity, so the hottest day of the year. But the hottest day of the year only happens maybe 2% of the time. So the other 98% of the time, we're running the system at full capacity, but it's not needed. So variable speed technology can work to match that load to the actual demand. So when we're running, say, we only need 80% of the capacity, 60% of the capacity, we can dial the system back, make sure that we're only running as much as we need to, and save a whole lot of energy in the meantime. And by the way, reduce wear and tear on your system because you're not running at full blast all the time.
Sure. You don't drive your car with a binary foot.
Exactly. My other point here is in kind of the age of COVID, where we have buildings that are operating at 50% capacity, 25% capacity. You don't need 100% of your HVAC system when, or they're only 25% of the people when. Building owners will be able to match that load demand to the actual load on the system. And so when we have fluctuating occupancy rates, variable speed technology can help there. In addition, now that we need airflow through a building all the time, indoor air quality is a big deal now as people return to their offices. Instead of having a system that's either on and the air is flowing or off and the air is not flowing, we can have a system that is not only matches the demand, but keeps air moving through the building all the time, even at a reduced speed.
And uses controls to dictate the power cycle.
Yeah. Exactly. Uses sophisticated controls. We can do it remotely from using the cloud or using a building management system. And this technology is all widely available.
With those variable speed technology, are they mainly in new equipment, OEM, or do you have a retrofit?
Yeah, they are available in new equipment, of course. But yeah, drives are a great technology because we can retrofit them to most motors that are out there. Most motors, whether it's on a fan or a pump, can be retrofitted using a variable frequency drive and become a very sophisticated motor in the process.
Where do you have the best success at reaching? Is it contractors, building owners, engineers? What's the target there? I mean, I'm sure you want awareness in all those groups, but...
Of course, it's interesting because even though this technology is pretty mature, there are not that many people, controls contractors or mechanical contractors that really understand it and can commission one of these systems. And I think that's one of the big problems and challenges that we've seen, and that utilities incentive programs, as they run out of low-hanging fruit in the LED world, are looking to drives to pick up the slack and become the next big energy saver. But the problem is that, yeah, you can put a drive on a motor, but the purchase is the easy part. The commissioning part and making sure that the programs are set up right and make sure that it's operating right is really difficult. And in a given market, when a larger market, say Chicago or New York, you may have more people that can do it. But I've been up to Burlington, Vermont, say, and dealing with the utility up there, Efficiency Vermont, and trying to do this. And there's maybe 2 or 3 people in the whole state that really are capable of doing some sophisticated drives installations and commissioning. So that's the problem. So we have some really great distributors that we work with who can help with the commissioning and help with the sale and get the customer there. And then Danfoss ourselves, we have a great training program where we invite contractors. We invite contractors to our Loves Park manufacturing facility. They can get certified, they can get training. It's really awesome. But that's one of the issues, is that there are just not enough great controls contractors and mechanical contractors out there that really understand the technology and how to apply it.
So that brings us to a good point of convergence or confluence. How do people find out more? Where can they learn about this? Do you want people contacting you, going to a website? What would you like to?
Yeah, please. You can contact me, john.sheff at danfoss.com, SHEFF, or you can go to our website at danfoss.us and see all of our technologies there. And I would be remiss if I didn't say I host my own podcast called the Envisioneering Exchange, where we discuss a lot of these issues. So you can find that anywhere you listen to your podcasts, on Apple Podcasts, Spotify, SoundCloud, the like, Envisioneering Exchange. And we discussed a lot of these issues, including variable speed technology, decarbonization, electrification, and a lot of stuff outside of HVAC as well.
Nice. I'll be sure to put that into the show notes so people can click right on that link.
Yeah, that'd be awesome.
Very interesting conversation. I really enjoyed it. Had no idea when you reached out where this would go, but I think when you showed me that little brief of those 4 points, I go like, yeah, this is good stuff.
Oh, good. Yeah.
I need to learn more. My listeners need to learn more.
I thought this was a great conversation. I really appreciate having me on here, Bill.
Any closing points you want to share with the listeners?
Yeah, I mean, there's a lot going on in the HVAC world, like we mentioned, electrification, decarbonization, but also the refrigerant transition is underway. And in the next couple of years, the industry is going through a lot of change. We're going to be going to new low GWP refrigerants. And if you're an HVAC contractor, this is something you need to know. There's a lot of information on the safe transition at the AHRI website, so please check that out.
Absolutely. We're good friends with those folks, and we'll be doing some webinars with them too to help communicate the message.
That's the big thing going on in the industry right now, aside from what we talked about today.
Very good. Thanks again, and I appreciate you coming on, and look forward to having you back at some point in the future. Really enjoyed the conversation.
Anytime. I'd love to do it.
Thank you for listening to this episode of the Building HVAC Science podcast. I also host the Res Talk podcast, where you can learn more about the rapidly expanding world of home energy ratings and peripheral topics. If you want to keep with other things I find interesting, follow us on Facebook by typing Building HVAC Science into the Facebook search bar. The Building HVAC Science podcast is a production of TrueTech Tools Limited. Thanks for listening, and we look forward to having you back again to listen more on the Building HVAC Science podcast. Take care.